Hello, everyone, and welcome. My name is Kagisho Ramatsa, an e-business consultant and a UNECE expert in transport and logistics domain. In this presentation, we will take a look at how to generate XML schemas from UNECE semantic standards, focusing mainly on the railway data standard using a specialist data modeling tool. What will you find out in this presentation? We will take a look at the technical environment and the data objects where the demonstration of generating such XML schemas will take place. Then we will get practical by taking you on a step-by-step XML schema generation from this data modeling tool. Then we will summarize our presentation. The environment is a data repository called UNECE projects, accessible through the link that is provided here on this slide. The data objects are the same SMGS consignment node, which are the subsets of the MMT RDM to be used for the purpose of the demonstration. The deliverables are published on the UNTTC website from this link, which are in this case the XML schemas that we will be generating and going through together. And these are published in collaboration between the UNECE and the UNECE. I would like to take this opportunity to demonstrate live from the modeling tool how to generate XML schemas from railway consignment nodes. We are now viewing the data modeling tool to be used for the generation of the XML schemas following the UNECE semantic standards and their naming and design rules on how to generate XML schemas. Here I have selected the environment that we discussed, which is the data repository. And within this repository, there are various of projects ongoing and also finished projects under the UNECE. We will focus mainly on the Eurasian Western European Union project on railway profiles as a subset of MMT. So from this project folder, I will go to the profiles or the subsets that are available where we will generate XML schema from. And as mentioned, this will be the same SMGS and the SMGS consignment node. But the process of generating such XML schemas, it is applicable to both of them. So for the purpose of the demonstration, we will have a look at the same SMGS consignment node on how to generate a schema from it. Using the right mouse click button or the context menu from this subset, which is a data model based on the MMT reference data model, I will do the right mouse click, go to the export, because this is what we are doing. We are exporting an XML schema. You may see that there are multiple options to select from, multiple outputs that we can generate from this data model. But our focus will be the ATG2 2.0 profile schema files, which follows the UNECE naming and design rules on how to generate XML schemas. You select this option, and the data model loads, and then the export dialog opens up. The first is to select the class or the root of the message from the data model. In this case, it has already been selected for us automatically, but for the purpose of demonstrating, we could see where this root class has been selected from the data model. And then now we go on to the next step. The next step is for us to select where we will want to have our XML schema or schemas being generated to be saved on. So I will save them on my C drive under a folder called temp, and then a specific folder called sim smgs. After having clicked from the previous dialog box, we now being presented with some automatic standard parameters for exporting UNCFET schemas. And this is provided automatically to you by the tool. These are the standard parameters that are used in terms of the generation of the schema from the UNCFET standards. Then you click on next. Additionally, as well here, these wizards are standard default for UNCFET, naming and design rules in defining the XML schemas. So you do not have to worry about this, and you don't have to configure this yourself, as automatically they are configured for you by the tool. This is the same as the other two wizards that we have went through, that just defines the properties of the version of the schema or the namespaces following the naming and design rules of the UNCFET. In this dialog, then you will have an option to define the parameters that allows you to have annotations, comments, and codes within your schemas, which is exactly what the UNCFET entails in generation of their schemas, as published also on their streamlined web pages. Then here we have some technical parameters as to what properties we would like to include in our schemas, and the UNCFET always follows this 4 of the properties to include within the schema. And of course, this means that the tool gives you more in terms of contextualizing your own schema if you want to see more information being included in your schema, which may not be provided when the schemas are published. But this you can include in your schema depending on your data requirements when adopting and reusing the XML schemas from the UNCFET. Also, more technical parameters being defined here on what to be included in the output of the XML schema. The documentation as selected on the screen, this is exactly what you have to follow. This is exactly what the UNCFET follows. And then you output the codes as well, which will be generated as separate schemas for you to implement or for you to import into your technical environment when implementing this XML schema. Then the next dialog then allows you to select what nodes you want to see, what nodes you want to have in your XML schema. And mostly we use the business name, which is the BN node, and as well as the publications from the UNCFET includes this business node. This is a business node that it is more understandable to the business people when they will look at such an XML schema. So it is not only including the technical names of the elements, the attributes, and the object within the schema, but also the business names that have been defined will be included in the resulting XML schema. So it is advisable to include this business node for the generation of your XML schema. And then now you are finished with generating your XML schema, or rather to say, defining the objects and the properties and the parameters to define such an XML schema. Then we click on finish from the tool. Then the tool will go on to generate the XML schema using in the background and applying the naming and design rules defined by the UNCFET to produce XML schema. Now, finally, when the XML schemas have been generated, you will then open the folder where you chose as the place where you will save this XML schemas. And within that folder, you have a folder called UNCFact, which is a folder that was defined in one of the parameters. And within here, then you will have your resulting XML schemas. The first one being the message structure, and then the others are the resulting code list that are used within the data model or within the subset, and which have been generated as separate XML schemas, but also could be linked to the main XML schema, which is the message structure. In addition, you have the qualified schemas, which are the links between the code list modules to the message structures. And then also you will have the unqualified, which is the unqualified data types that are used for all the base data types, and the ones that without any codes linked to them, e.g. the ones that has a data type of a text will then be defined in this unqualified data type schemas. So then finally, you can take this, adopt them, and then use them within your implementation project. Closing off, I will go back to the presentation to have a look at the summary for our presentation. So in closing off, the production of this XML schemas, it is done following the UNCFact naming and design rules. And they are the UNCFact official syntax format output that are published amongst the UNCFact semantics reference data standards. These generated schemas, which are available as XSD files, can be used directly in various implementation projects, and they can also be customized to fit a particular implementation use case. As you might have been aware from the dialog box of generating the XML schemas, you had options to include some properties in addition to what is being provided by the UNCFact or followed by the UNCFact. More information about the UNCFact semantic standards then can be found on the link provided from their website. With this, I would like to say thank you. I hope this video was useful for you. Bye.